Okay, so we know what an angle is. Now it's time to start using it a little bit. That's what the rest of Chapter 5 is about. So Chapter 5.2, Section 5.2, I should say, is some basic applications of these angles. All right, so remember that the formal definition of a radian, theta, in radians, was what? What was a radian? We developed it, and y'all were like, ooh, now I know what that is. We've been using it in science. I had no idea, but now I know. It's a unitless measure of rotation, and the reason it was unitless is because it was a ratio of one length to another length, and those units of length divided out, right? Inches over inches, feet over feet. What were we measuring, though? What was it the ratio of? What two lengths? The radius, or part of the circumference, which we call what? What's part of a circle called? Last night, Donald Trump, thank you. He invited the Clemson Tigers over to celebrate their national championship, and because the White House cooking staff is on furlough, they had, yes, please do, thank you. Yeah, gosh, thanks. Anyway, he had fast food for them. So they came in and they were like these silver trays and these glorious candelabras, and they had like stacked Big Macs and stacked Wendy's and pizzas all on silver platters. So anyway, thinking of McDonald's is the golden what? Arches, yeah. So part of a circle is called an arc. Yeah, I don't know. I was trying to give you kind of like a news thing and related to what we're doing. So thank you, Cheyenne. We just downloaded 5.2. And when I say thank you, I mean thank you for not hating me or judging me for leaving you out in the hall. It's not that I forgot about you, but I did forget about you, okay? And I just get so excited about the math that really nothing else matters. I get this tunnel vision. I get this singular, narrow-minded focus, craving for my insatiable appetite of math, and I just go for it, and I forget everything else. It's called arc length, and we use the letter S, right, from the Greek stadia. This is just all review. Okay. Now, this is a formula or called a literal equation because it literally has letters in it. That's literally what literal means, by the letter. So we can manipulate these symbols around, can't we? Yes, thank you. Good. So if I just solved for S by multiplying both sides by R, it would divide out on the right times R, and it would be introduced over here, R times theta. Now it's solved for S, arc length. So that brings us to this first formula. If theta is the central angle of a circle whose radius is R, where theta is measured in radians, then the arc length, S, of an intercepted arc, remember the angle subtends the arc we say intercepts the angle, we get S equals R theta. S equals R theta. And of course, theta, don't forget, is in radians. So from the definition of a radian, we can derive essentially a formula that tells us very quickly, without having to use proportions, which might also work, how far we've traveled around the circumference of a circle for a given angle in theta. Okay, let's see how we can use that. Example 1, find the distance a runner travels in miles along a circular track. Okay, so a lot of tracks around stadiums are not circular because they're usually wrapped around a football field. But let's say that in an ideal world, we have a perfectly circular jogging track. And look at this track. It has a radius of 5 miles. If that runner runs on that track then through an angle of 300 degrees, not through a temperature of 300 degrees, because then he'd be dead, but rather through an angle of 300 degrees. So some cities that are well planned have like jogging trails throughout and a lot of green space for people to enjoy. So let's say we have this ideal community and there is a track all the way around the community and the radius of the track is 5 miles. Okay? Wouldn't that be great? And then the city is all in here in the interior, right? And then you have and then the city expands, out here. you know, and then, but you still got that 5-mile track, right? And the von Thunen model of proximal development still works, right? If you've had human geography. You put the horses farthest out where the land is cheapest and transportation costs are less, because it's kind of sad, but when you're a rancher, your goods and services transport themselves to market. It's kind of sad if you think about it. But anyway, that's human geography. So let's have this runner start right here. And we're going to start on the positive x-axis. In other words, let's superimpose a coordinate plane over it, and let's start in the standard position. All right, so let's go ahead and pretend we're the runner. We're going to run through 300 degrees rotation. Run, run, run. Hurry, hurry, hurry. Run, run, run. Hurry, hurry, hurry. Pace yourself. Drink lots of water. Cramp. Stretch. Keep running. Run, run. Hurry, hurry, hurry. You got the idea? Where does 300 degrees terminate? About right here. Okay? So that's 300 degrees. And he didn't quite make it all the way around. Now, before you, laugh at him for dude, you didn't even go one lap, right? You're so out of shape, you can't even do one lap. We better see how far he actually went, okay? Because remember, the radius of that track is 5 miles, not 50 feet, okay? Okay, so that means that we are interested in finding the arc length, which would be, let me highlight it. I got to always do it twice for y'all for some reason. There. That's the arc length S that we're trying to find. So let's pull out the handy-dandy formula, which you have to memorize. S equals R theta. Well, let's just plug in. S is equal to R, that's 5. And if you put your units in there, that's a good check. That's a good verification that you're going to get the right answer. Times theta is 300 degrees. Now, if you multiply those two together, you're going to get 1,500. And what are the units? Miles times degrees. So that guy finishes his run, he goes home and takes a shower, and then he goes to work that day, and he brags to all of his coworkers that he's a vegan, like we've heard that, and that he just finished running 1,500 miles degrees. And the coworkers are, stay away from that guy, leave me alone. They're going to go to HR and say, can you fire him or get a restraining order? Okay? Because what's wrong with that? First of all, he's boasting. I ran 500 miles degrees. Yeah, there's 2 units in there, and we're trying to figure out how far he ran. We measured distance in this case in miles, not miles degree. So, man, the degrees kind of mess it up. They make that story into a nightmare, right? If you would have just stopped at miles, I would have been like, okay, you ran 1,500 miles. Yeah, right. That's not even a reasonable number, is it? He ran 1,500 miles? That's not even reasonable. So there's a couple of things wrong with this, okay? So only the degrees messed it up. It gave us an unwanted unit of degrees. It also unnecessarily was inflating the distance he ran. 300 is too big of a number. So, man, if only there were another way to measure rotation besides degrees that were unitless, because then we would have miles times unitless, which would be miles, right? Is there such a unitless measure of rotation? Yes, it's called a what? It's a rad. So you must be very careful. When you use this formula, since it comes from the definition of a radian, your theta must be in radians. So if I give you an angle in degrees, you can either A, go off to the side and convert 300 degrees, put it over 1, multiply by pi over 180 degrees. And you'll see that your degrees divide out. Now, when you pull out your calculator, remember you want pi visible in your answer, if you can. You just go 300 divided by 180, and then you hit math, enter, enter. And you should get 5/3. Do you? Yeah. 300 divided by 180 gives you a decimal, and then you hit math, enter, enter, and it should give you 5/3. So that ends up being 5 pi-thirds. Radians, okay? So that's the angle that you want. and then you could plug it back in. So this is actually incorrect. So this really equals 5 miles now times 5 pi thirds. And what are the units of 5 pi thirds? Yeah, nothing really, but radians is a description, okay? So now check your units. What's miles times radians? Miles, because radians are not units, right? Now let's go ahead and compute that number. That's 5 over 1, so that ends up being 25 pi thirds miles. Now, that would also be annoying if that guy came into work and like, hey, dudes, not only am I a vegan and I do CrossFit 3 times a week, but I just finished running 25 pi thirds miles. And you're going to be like, get away from me. You do this every day, Chad. Okay, whatever his name is. Yeah. Sure. Yeah, I don't know. I roomed with a guy named Chad in college, and he was a really good friend of mine. Chad, if you're listening, I love you, man. Huh? Was he what? No, he was not a vegan. He was actually a really, really clever, crafty. He's now a mechanical engineer. He's a good guy. He's got a great family. Love you, Chad. He was in my wedding. Love you, Chad. I've been married 22 happy years because of you, Chad. Because you were at my wedding. You were there to see me through. So I have nothing against Chad. But really, if he tells you I ran 25 pi thirds miles, you're like, dude, who talks like that? All right? So when we have angles, we prefer pi visible. But when we're talking about distances and lengths, that's kind of a funky number. So here's what I would recommend. 25 pi thirds is nice. I'll give you that, Chad, because it's an exact answer. It's exact. But let's go ahead and see what that is to 3 decimals. So 25 times pi, or just 25 pi, divided by 3. That's 26.179 or 180. You would need that 3rd decimal miles. Okay? There you go. Now Chad can come in and say, hey, guys, good to see you this morning. And everyone's like, hey, I saw you running on the track on my way into work this morning. How'd you do? Well, I don't really like to talk about myself, but since you saw me, I was running around the city track. Oh, man, that is a huge track. What'd you do? I did 26.179 miles. See, so now you're not a jerk for just walking in and saying, guess what I did, right? You're just answering someone's question who's legitimately asking because they care about you because you're a nice person. All right? So that's it, 26.179 miles. Now, if he would have gone maybe like 3 extra steps, like 1, 2, 3 extra steps, he could have probably run 26.2 miles, right? And what is the significance of 26.2? That's the length of a current marathon, right? Now, do you think that if Chad, the second Chad, who reports 26.17 miles only after being elicited for that information, do you think he would be the kind of guy that would put that 26.2 sticker on the back of his car? That's just an opinion. I don't know. I think the first Chad would. The first Chad, though, probably wouldn't put 26.2 on the back of his car, right? He'd put like 25 pi thirds plus 0.1. And people were like, dude, right? But no, I don't think the second Chad would. Because, he's not into boasting or bragging. He's staying humble. Okay? There you go. Comments or questions on that? Yes, good. Is there another way to do it? And the answer is yes. Okay? We can say S equals R theta. And I would recommend writing that out each time just because it's a reminder what the formula is that you have to memorize. And now let's just plug in. Again, I'll use units just to make sure I'm doing it right. 5 miles times 300 degrees. Now, a real quick unit check, I'm like, that's going to give me miles degrees. I don't like that. So rather than converting off to the side, is it legal to go ahead and convert right there in the problem? Sure, it is. It absolutely is. Because we're multiplying by something, but this is equivalent to what? 1. And 1 is the identity element of multiplication. So yes, you can actually do it that way. And you're going to end up with the same thing. You're going to end with 25 pi thirds or approximately 26.179 miles. Remember to put units on all your final answers, but you don't have to on the intermediate, although it could be helpful. Okay, cool. So that would be really, really neat to have a track around a city that was safe, where if you did one lap, you're running a marathon. That would be great every day. My goal is to run one lap a day, right? Yeah. Okay. Take you anywhere from like 2 hours and like 2 minutes, which is currently, I think, the world record. They're approaching 2 hours, up to many hours, right? 4, 5, 6, 7. I think most marathons, they cut it off after 8. They don't want people just to enter into a marathon and just walk the whole thing, finish 3 days later, and then get the medal and the T-shirt, right? Because that's not the same. Okay, but anyway, that's cool. I wish our city had some kind of greenbelt space like that other than Panther Canyon. That was nicely wooded, you know, not just like open prairie land. So anyway, any questions on that? S equals what? Without looking? R theta, where theta is in radians. Okay, good. Number 2, if the same runner on the same track from example 1, y'all remember him? Yeah, Chad. Okay. If he runs an ultra marathon, what the heck? Ultra marathons are pretty much anything that most people don't do. Okay? Like, people have a bucket list of I want to run a marathon. Okay? If you're not a runner, if you're just a casual person, you know, most people don't I want to run an ultra marathon, because that's usually anything that's 100 miles or longer, and they're usually like from treacherous through treacherous places. Like there's one that's I think it's 100 miles, but you know, it starts in Death Valley, California, where it's very low and very, very excruciatingly hot, and it ends at the top of Mount Whitney. So you're talking about not just a 100-mile run through, like, heated temperatures and cool temperatures, but it's a lot of elevation gain. Like, that's insane, right? But there are people that do that. There's people that do that. And they train for that like y'all train for your math homework, right? That's why y'all are so good. Y'all do y'all's worksheets over and over again. You train like that. So he's running around the same track. How many degrees is he going to have to run through? In other words, how many laps is he going to have to make to do an ultra marathon on that track? Well, we're trying to figure out through how many degrees, so we're trying to figure out essentially the angle theta, correct? If we know that 150 miles has to be what in that formula? He's starting here. He's running all the way around. He's probably going to have to go around once, twice. So that would be his arc length that he travels. So you can actually go around more than once. And, of course, we know the radius of the track is 5. So we're still going to use the same formula, S equals R theta. We can now plug in what we know and then solve. So if we do that, the arc length he's trying to run is 150 miles. The radius is 5 miles, and we're trying to figure out theta. So if you solve for theta,
teachers, the bells were not changed from yesterday's assembly schedule. So bells did ring a little bit early, but we are going to go ahead and go to second period at this time.
What?
We will have those bells changed.
Wait. We have like 5 more minutes. Let me finish this one problem. If we're not on the bell schedule, we have 5 minutes still. So let's just finish this one problem. You get theta equals 150 divided by 5, which is 30 what? Rads, good. So that's the definition of a radian. But we wanted how many degrees? So I'll let you go a little early, but let's just finish this. That's 180 over pi rads. We got to convert it back now, and your rads divide out. Now, because we want to figure out the angle theta, notice pi is in the denominator. So let's just go ahead and just type it in. Unless pi is in the numerator, we'll just type it in. So that's going to be 30 times 180, and then we're going to divide it by pi. Divide it by pi, and we get that, 1718.873 degrees. That's how many degrees he has to run to, okay? All right, if you want to divide that by 360, this tells you how many laps he has to run. 4 full laps and a little over 3/4 of the other one. All right, there you go. You are still going to get to class plenty early. I don't make the rules. I just work here, people. Have a great rest of your day.